talk about the bearings. Let's talk about bearings. But before we do that, we have to introduce to you the concept of a vector. How many of you are in physics right now, currently, or have had physics? All right, so you guys probably know the concept of a vector, correct? So a vector is represented by an arrow, and that arrow shows you two things.
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! With both direction and magnitude. Oh yeah! Oh yeah!
All right, so what are the two things that vectors show? See, look at that. You can't learn something from TV. You said that. You're right. All right, so we learned that a vector shows magnitude and direction. Oh, yeah. And it was not bad. It was actually very good. Thank you very much.
Fire shirt. What is that?
Drum set.
I can see that in your shoe.
Drum shirt. It's on fire though.
Oh, that's
I have another fire shirt that I think I've misplaced it. It's a bagel that's on fire.
Ooh,
Yeah,
that makes sense.
bagel is but I don't know where I put it.
All I get is
On fire bagel. Okay, anyway. So back to vectors. So if they show magnitude and direction, that would mean given some arrowhead. See, look at I'm always looking in the wrong place. So here we have a vector. And there are two parts to this vector. There's a tail and a head. And the tail is where we began, and the head is where we end. And when you have vector geometry, which unfortunately we don't get to do it here, but someday we will because we're going to revamp it. And in vector geometry, you add vectors together. And when you add vectors together, you add their heads, their tails to the heads of the previous vector. So, for example, say I wanted to take this vector that I have drawn, and I wanted to add another one to it. I would go from the head of vector 1 and create vector 2. So you always go tail to head, tail to head. So when we draw these things, keep that in mind. And then we get a different kind of vector. If I wanted to go from the beginning of the vector that I began with, and I want to end at the second vector, this has a special name to it, actually. You guys know? Oh, no. You guys know what this is called for you physics folks? Thank you for the enthusiasm. No, I don't know what it's called. It actually sucks. What is that thing called? You even know? That red vector is called a resultant. Okay, well, you're learning it here, sister. It's called a resultant vector. And that's the one that we get when we add vectors together. So we're going to do this type of thing with section 9.5. Application, most of it, surveying, navigation, things like that. So, anyway, compass world. Here it is. Here's our compass and bearings. And we have bearings that turn from north and spin clockwise around. So 90 degrees would be east, 180 would be south, 270 would be west, and then 360 back up on the 0. Then we can have what we refer to as surveying type bearings, and they are bearings that turn from either a north or a south. And we'll take a look at that in our first example. So you might have seen problems that say you've gone north 14 degrees east, or north 87 degrees west, or something like that, or south 7 degrees west. Something like that is called a compass bearing. And they turn from either north or south. So if I ask you for bearings on a test or a quiz problem, I'm going to want you to give me our 0 to whatever answer. All right? So here we have our very first example. Notice who's going for a walk. Biff and Buffy. Biff and Buffy are going for a walk. Is this just no? No.
Wait, where is Biff from?
Biff.
Who is it from? Biff?
Back to the Future.
There you go.
Biff. Right. All right. Anyway, I got all this. No, Buffy is just Buffy. Forget the names, people. Okay. Regroup.
Hey, do you know that April 30th was the day that they went to? 2013 in Back to the Future?
Yes, 2015.
That's amazing. What's the relevance?
Because
That's the day that
Okay, thank you.
I don't think I'm looking for it.
Okay, regroup. Zip it.
No, I did not see that smaller.
So on these problems, the hardest part is going to be, for some of us, the hardest part is going to be the sketch. But it's the most important part. So I have helped you with this one. We're going to talk about our walk. And we're going from their cabin, and we're going to proceed north. So we're going straight up from your cabin, 6 miles. Then we're going to turn 40 degrees towards the east. And then walk another 4 miles. And then end up at some spot. And then we're going to answer these questions for A and B. What's the sketch? Because again, that's important. And I need to see sketches for all these problems. And then how far are we from the cabin? And we're also going to answer the question of what is their bearing? All right, so from the cabin to where they end up, what was the bearing? So here's the little sketch. And notice it's in proportion. 6 miles, a longer arrow. Going vertically because you're heading north. So think of a compass. And then we get to some point, all right? We get to some point, there's a fork in the road, there's a sign that says, hey, Biff and Buffy, go that way. And they turn an angle. Now, when you turn an angle, also another word you might see for bearing. I don't know what's going on there. Try to communicate. No, we're not going to. All right. So course would be synonymous with bearing. In fact, your homework has some problems saying you're on a course of 400 degrees, you're not 400, 40 degrees. All right, so we're turning towards the east, so it means we're going to the right, 40 degrees. And we walk another 4 miles, and we end up at our destination point. So we're going to find, how many of you heard the term as the crow flies? Okay, so the term as the crow flies means from point A to point B in a straight line. Well, all lines are straight, right? So in a line to those points, that's the as the crow flies. So we're going to just call, for the sake of labeling, we're going to call this length D. And that is one of the things we're looking for, is how long is it from where the cabin is to where they ended up. And then we're also going to add on to this some bearing stuff, so we'll do that in just a second. How would I do this? No, we're not going to make right triangles. We don't need to make right triangles. Don't need to. What?
You make like 160 degree angle.
160 degree angle? You sure want to go 160? 140, right? So look at this. These two angles here, the 40 degrees that we turned to the east, and then the other one that's left over, are supplementary. So that means they're going to be adding to 180, which means that blue angle there is 140 degrees. All right, so that's cool. Yes, Eric?
I was just saying, what to do next.
Well, all right, what do I do next?
Can you use long cosine?
Yes, you can. In fact, that's the only thing I can use right now. Can't use law of sines. I have a side, an included angle, and a side, which allows me to use law of cosines to find b. So that's what we're going to do. So we're going to set it up. B squared would equal the length of my two sides, the sum of those squared. So I'm going to have 6 squared plus 4 squared minus 2 times those sides times the cosine of that angle, which in this case is 140 degrees. And somebody's going to help me out here and give me this value. Say that again.
I got 83.
So 9.6? 9.4? Is that right? Alright, so 9.4 miles. There's the distance from the cabin to where they ended up as the crow flies. Alright, that's not the distance they walked. They walked longer than that. But if you were to just draw a line between where they are and where they've been from, that would be 9.4 miles away. Now we're going to add on to this. We're going to find out what is their bearing. And we'll do the bearing from the cabin to where they ended up. So we can get this concept of bearing. This is the piece you need to get down. So what you're going to do is you're always going to start these drawings, sketches by, here's my point where I am at, wherever that is. And then you're going to always draw a vertical line from that point because you're always referencing north when you talk about bearings. So we've already got our vertical line in. It's already right there. And then what we're doing for bearing is we're turning clockwise until we land on, in this case, this dashed red line, which represents the vector for where I end up. And so I'm looking for that angle right there. That's the bearing that I want to find. From north to wherever I'm supposed to go. Right? So connect the dots. And that's the distance that we just found of 9.4 miles. But we need to find out this angle here. We'll call this angle C since we're at the cabin. So now, how do I do that? How do I find this angle of that little triangle? Now I can use law of sines. And this is often the pattern. You use law of cosines to find a missing side. Then you use law of sines. Now, could I use law of cosines again? Yeah, I could use law of cosines again. This law of sines tends to be a little quicker. All right, so sine of angle C, the cabin, over 4, the side across from the cabin, is equal to the sine of the 140-degree angle over the 9.4 distance across from that. Now, I'll get two values of C, because every time I take sine C and I do inverse, I get two answers. But I don't need both answers, because this is a single triangle. So I'm not thinking ambiguous case, I don't have to worry about that. We just go find C. And C equals, somebody tell me else, 4 times the sine of 140, and then that answer divided by 9.4. 15.8? All right. So 15.8 degrees. Now, oftentimes, bearing information should also be written as degrees, minutes, and seconds. So, just add the 100. So it's 15.86, you said? 87. So let's just review. How do we write things in degrees, minutes, and seconds for decimal degrees? Do you guys remember how we do this? All right. Here's how we do it. From decimal degrees to degrees, minutes, and seconds. You take the 15.87 degrees, and that's going to become 15 degrees plus the decimal value times 60, and this is what's going to convert you into minutes. So that's going to become minutes. So somebody do that for me first. 0.87 times 60 gives me... Say that again. Okay, so 15 degrees plus 52 minutes, and then you said it was 0.2? Yeah. So it was really, so this thing became 52.2. And now what we're doing to find the seconds is we're taking the decimal portion of those minutes, and we multiply it by 60. And now this creates seconds. So 20% of 60 is 12. So what is my final answer in degrees, minutes, seconds? 15 degrees, 52 minutes, 12 seconds. It's the same thing as 15.87. Cool? Degree, minute, second conversion from decimal degrees. Yes, sir.
How is angle C, which is in
cabin. How's that the bearing?
Oh, okay, so how is this the bearing?
Yeah.
So bearing, remember, is an angle turned from north. And I turned to the right from north. And I turned to the right 15.87 degrees.
Cabin is north.
No, the line from my cabin is north. So wherever you are is your points. That's why you got to put vertical lines at all my points. So the north is from the cabin, and I perfect.
Are we gonna know how to find EMS?
That's what a deal is I made third period. Convert things to degrees, make seconds, I give you extra credit. Yep. Can I explain bearing again? Compass. Compass, north, south, east, west. North is 0, and then you would go clockwise for your angle. So 90 degrees is east, 180 south, 270 is west, and back up is. So that's the difference between polar, which goes 0 out to the right, and then goes counterclockwise. 90, 180. The bearing is the compass point. 0, 90. Yes, ma'am. Don't physically add it? What do you mean? Oh, yeah, no, I'm just writing it. Yeah, I won't write it with a plus sign. I'll just take whatever like 0.87 times 60 comes to 52.2. The whole number part of that decimal is the thing that becomes the minutes. And then I do this 0.2 times 60, and that part becomes the 60. So I'm not physically, yeah, right, I'm not adding them together. I'm just writing them as degree, minute, second. Yes? Yes? Yeah.
If you're writing your final answer, you want it to be like 9.42 miles east. At 15 degrees, blah blah blah. East of north.
Okay, good question. So if we're writing our final answer, what do I need to have you do? And in terms of a bearing, again, if I say I want a compass reading, that's what I'm going to measure from a north or a south. And the compass readings are always going to be acute angles. I'm not going to probably ask you for compass readings. So instead, if I say, give me a bearing, all you need to say, you don't have to say east, because you always turn east for a bearing when you roll positive. All you need to physically do is show me that angle. There's your bearing. Yes?
So you're turning west is negative?
Yeah, turning west to be negative, but again, bearings, generally, with navigation purposes, surveying purposes, will always be talking about a positive answer. If you wanted to express something going left, which is a west turn, that's when you would say north, 15 degrees west, and then that's representing my negative angle. That's when I'd be referring to a north-south line. Again, compass reading versus compass bearing. Yeah.
So we're never gonna ask us, like, where you don't want it to negative, like,
No. Don't
so
give
if
me
it goes west, we just say north and west.
No, you don't even need to do that. Again, this went east, right? So I don't need to say that it went east. I'll know that it went east because it's 15 degrees, which is positive, which is already turning to the east. I don't need you to specify. If you wanted, again, back to his question, if you wanted to express it like a compass reading, you would say north, 15 degrees, 52 minutes, 12 seconds to the east. So you'd say it that way. It would be written as 15 degrees, 52 minutes, 12 seconds east. That would be the same thing as just a bearing.
And if it's to the west, we just replace east with
We
west.
would go to the west, yeah. But again, I will primarily be looking for you to give me the bearing, which is a 0 to 360 number. Okay? All the way around. All right, good questions. What else do you have on this one? The trickiest part is going to be doing the drawing. So if you get the drawing right, then you're in golden shape. If you don't get the drawing right. So if that's the case, find what this looks like. Read it carefully. Draw a sketch for me of what's happening here between Village T, Village B, Town T, and City C. What's happening? I want you to start with just a point that represents, in this case, we're going to start at town T, village D. So I'm going to just put a point on my paper somewhere, and that's village D. So I'll put a B. And then from that point, I want you to draw a vertical line. Who cares how long it is right now? You're going to just draw a vertical line. And then I want you to imagine laying a protractor on the board right there. So, don't fancy that, I actually have a protractor. Look at that protractor, it's a monster. Alright, so I'm going to take this thing, I'm going to spin it around. Does that look vertical to you? No. There we go. And I'm going to take that protractor, I'm going to set the, I'm going to set the center of that protractor at village B. And then here's how you figure out what your angle is. So we always come from north. So I'm coming from that red line vertically that we drew, and I'm spinning around northeast, which means halfway between north and east. Halfway between north and east is 45. So we would spin our protractor around, or we would measure until I go 45, which is a little tick mark right there on the protractor. All right, move the protractor out of the way. I connect. There's town T. 45 degrees from the north. And it's 8 kilometers. And now we're going to do this again. Now we got to go find village C, or city C. I draw a vertical line. Imagine a protractor coming. Whoa! Imagine, oh boy. Because it says northeast. I know, there's the answer right there. I'm trying to grab this thing and move it, but it's not cooperating with me. Move. There we go. So I come over here. I stick my protractor up there again. And now it says I want to go 150 degrees from the north. So the north is vertical. I look on my protractor until I get to 150, which is right there. What's going on? Oh, my pen isn't working. There it is. And then I can move that protractor out of the way. In fact, let's just get rid of the protractor. Whoa. Hello, protractor. Cut. Bye. And there is my 150 degrees. But the length of it's only going to be half of what the 8 was, because the vector is represented magnitude by the length. So I'm going to go half of it. So there's 150. And now I'm at city C. And then we are supposed to find the bearing in the distance of C. Read that carefully. Of C from V. So that means go hang out at V and look at C. So that's what I'm doing right there. So there's our sketch. And every time I went to a point, I put a vertical line in. From that vertical line, I turned my angle. So you guys have something that looks like this? Pretty, yeah? All right, then we're going to go find the bearing and the distance. Okay, we got to find our distance. We'll call this line segment BC, because that's what we're looking for. Oops, we got to put some information in here for angles first. All right, so help me. We said this was northeast, so that means that's 45. And because of transversal and parallel lines, I know that this is an alternate interior angle to that other one of 45 degrees, so that means that angle is going to be 45. How do I know it's 30? All right, good deal. So if this is a 150 bearing, that means the leftovers is 30, which means this whole angle is 75 degrees. And now I have enough information, side, angle, side, to be able to find line segment BC. Again, through law of cosine. So we set this all up. A squared plus 4 squared minus 2 times 8 times 4 times the cosine of 75. And I think it is 7.96. I think it's 7.96. Do I remember that correctly? Okay, now that's the distance part. But we're supposed to find also the bearing part. Now again, we're going from V to C. That means in my drawing, I need to know this angle. From the north line at V to the line that I get here of V to C. Those are called sight lines. Sight line V to C. All right, any brainstorms? How we're going to find that? Yes, ma'am? Okay, good job. So we're going to use law of sines to find this angle. And then when I find that angle, I will add it to 45, and I will have my bearing. So let's call that angle B here. Sine of B over 4, which is across from that angle, equals sine of 75 over the number we just found, 7.96, and what was it, 29? I think B is 29 degrees, if I do this correctly. Angle B is 29. And therefore, we can say our bearing.
Wouldn't you have 45?
Say that again?
Wouldn't you have 45?
Yep. So our bearing would be the 45 degrees plus the 29, or 74 degrees. So there's all of our information. And this would be bearing V to C. That's how you can write it like that. V to C. Yes, sir. If it actually had a degree, decimal degrees, then yeah, you can still do degrees in a second. So that one pretty much goes to 29, right? Is it a 29.03 or something like that? Yeah, I'm fine with 29. Yes, Julius.
Can you explain alternate interior, please?
Sir, alternate interiors. So give me two parallel lines. Cross those two parallel lines with another line called a transversal. If that happens, the angles that are inside of the parallel lines but on opposite sides of the transversal are called alternate interiors. And they're always going to be the same thing. And then you have things like vertical angles, stuff like that. So that's the concept of an alternate. All right, good question there. Anything else on this one? You good on this? There you go. So we get that. That should have been our drawing, something that looks like that. And then we're trying to find the total distance traveled, so that means you're finding the three sides. You gonna have a number for me? What do you got, Cameron? Yeah.
2,327.63 kilometers.
2,327.63 works for me. Yeah. So finding the parts. Let's go ahead and look at the parts. So this would be, we'll call that little side A, and this is little side B. We set up, I've got three angles with a side. I could use a lot of sines here if I wanted to. So if I wanted to find little a, I'd set up law of sines. Somebody have this number for me? What's this number, this vertical part? 919.25. Do the same thing for B. Somebody got this number for me? 808.3. And we add them all up, we get to 2327. Alright, so you see once we just get our triangles built, it's a matter of figuring out which law to use and then we're good to go. Does this seem too terribly difficult? No. Julius?
I think 40 degrees.
How do you get to 40 degrees? It told me that. It told me that my return course is 40 degrees from where I started. So if I start at A, I go 300 degrees, I get to a new point. Then it says from that point I go south. I get to a new point after I fly for so many hours. And then from this point I'm turning 40 degrees, which is coming from north, so that's how I know the best. This one over here, yes. Yep. All right. There we go.